All right, backside here. Since we know that we're gonna follow a step function, okay, we're just gonna take the greatest integer and subtract 5. I'm not gonna worry about decimals anymore now that you kind of have the idea. So let's start with -4, -3, -2, -1, 0, 1, 2. Let's see what happens. Okay, so this function here means take the greatest integer, then subtract 5. Okay, so we're gonna have to take the greatest integer of -4, then subtract 5. And since I've chosen integers, well, that's just gonna be itself. So -4 minus 5 is -9. All right, this may go off the graph, that's okay. We can just graph what is on the graph. So this would be equivalent to -3 minus 5, so -8. Then I have -2 minus 5, -7, -6, -5, -4, and -3. Okay. 1, 2, 3, 4, 5. Okay, my graph only goes up to 5. Anyway, either way. So let's just graph that part and we'll continue our step function. Okay, so at 0, I need a line going across at -5. Okay, and then we always start with close, then open, unless there's some kind of negative sign or with your x. Okay, so we're gonna go to 0. That needs to be at -5. I'm gonna close it first and then open. Then at 1, I need to be at -4. Closed, open. Okay, at 2, I need to be at -3, so closed, open, so on and so forth. Okay, like I said, we only have to graph what it covers the graph, so that's fine. Okay, and our domain, did it change? Well, no, this would continue, open. This would continue on the other side forever and ever. That's all real. And then our range, well, that didn't change either. These are still all integer values. So we're gonna give that integers, okay? All right, let's do the next one. So I need to figure out what the value is gonna be. I'll just do decimals for this just so you can get some more practice with integers. Our greatest integer, until we kind of understand it. Okay, so at 0, this would be 2 times the greatest integer of 0 minus 1. The greatest integer of 0 minus 1 is -1. So 2 times -1 is -2. Okay, and now let's try that with a half. So 2 times the greatest integer of 0 minus 0.5, minus 1 is going to be 2 times the greatest integer of -0.5. Remember, we can't round up to 0. We have to round down. So that's also -2, okay? Now let me do the greatest integer of 1 on the left side. So I'll have 2 times the greatest integer of 1 minus 1, and that's 0. If you get an integer answer, then it's just itself, okay? So 2 times 0 is 0. All right, let's do 1.5. So 2 times the greatest integer of 1.5 minus 1. Well, 1.5 minus 1 is a half, so 2 times the greatest integer of a half. Remember, we can't round up to 1, so this has to be 0. So that's also 0, okay? And we should know that because these should not change their value until you hit the next integer, 2. Okay? So let me try and see what 2 would be down here. So 2 times the greatest integer of 2 minus 1 would be 2 times 1. That's 2. And obviously if I plug in 2.5, I should get 2. I'm not going to have a value change until I get to the next integer. Okay, so we'll try 3 now. That would be 2 times the greatest integer of 3 minus 1. That's 2 times 2, 4. Okay, so these are not going up by 1 anymore. They're going up by 2. Okay, and that kind of makes sense with the graph because I'm having 2 times something going on. Well, then I should expect a double change. Okay, so at 0, we're at -2 and a closed circle. I'm going to open my circle. Okay, and then at 1, I'm at 0, so I moved up 2 this time. I'm going to open the circle. And then at 2, I'm at 2. Okay, so I'm going to close circle. And then at 3, I'm at 4. So that's moved up to 4 here. Close circle, open. Okay? And if we were to reverse it, we would have to go down 2 and then change the way you're open and close. Like follow the pattern. So I go open, closed if I'm going backwards. Excuse me. Okay, so again, our domain is all real. And what's happening with the range? Are these all integers? Well, am I hitting -3 with a y value? Remember, in range, we care about the y's. Is there a value of -3 anywhere on the graph? No. What about -1? 1. 3? No. Okay. So our range is integers, or even integers, we should say. I'll rewrite that, okay. Even integers. So y has to be even and integer. No decimal. All right. All right, last one, and this time we have something inside of our greatest integer function. Okay, so I'm gonna actually pick the same domain here so we can see what happens with our decimal. Let's pick the same domain. So I'll start with 0, go to 0.5, 1, 1.5, 2, 2.5, and 3. Okay, and let's see what happens. All right, so for 0, we have the greatest integer of 1/2 times 0 plus 4, which is 0 plus 4. And your greatest integer, and that's 4. Okay. So what should 0.5 be? 0.5 should be exactly the same as 0. I can't round up, or the y should not change until I hit an integer. Okay, and let's see what happens when we hit 1. So I'll have 1/2 times 1 plus 4, and that would give me 0.5 plus 4, which is 3.5. 4.5. Whoops. 4.5. Okay, so what is that greatest integer of 4.5? Well, I can't round up to 5. So I have to go down to 4. Okay, so look, I'm at an integer and I'm getting a 4 out. Okay, so this one's actually not going to change until every other integer because just because of the way the function is, I'm taking half of it first. Okay, so 1.5 should still be 4. You can plug it in if you can't see that. All right, let's test 2. So I'll have the greatest integer of 1/2 times 2 plus 4. Okay, this would be the greatest integer of 1 plus 4, 5. Okay, well, that's an integer already, so 5. I don't need to take the greatest integer, it is 5. Okay, and if I did 2.5, let's do that down here. We're getting 1/2 of 2.5 plus 4. Okay, that would be 1.25 plus 4. 5.25. And that greatest integer is 5. Okay? And if you plug in 3, you're also going to get 5. It's actually not going to change until you hit 4. Then it'll go up to 6. Okay? So this is changing every other integer, which means from 0 to 1, it's 4. Sorry. From 0 to 2, it's going to be 4. So this just kind of makes our steps a little longer. All right, so at 0, I have a closed circle, and the value is 4 until I hit 2. Okay? Then at 2, my value jumps to 5, and it actually stays 5 until I hit 4. And that value will jump up. Okay? So let's reverse this. I'm still going down by 1, but it's going to take up 2x values now. Okay, so when I'm at -2, I should still be getting 3 until I hit 0. Then when I'm at -4, I should be getting 2. And you can plug those in if you want to see. Okay. All right. So our domain here, from left to right, there's still a value, even though it jumps, there's a value for all real. Because these still go on forever and ever, not just the part you see on your graph. Okay, and our range, well, unlike before, unlike graph 5, we do actually have a value at every single integer. Okay, 2, 3, 4, 5. We do have a value at every integer. So this is just all integers. Okay, that's it.